I'm going to introduce our last speaker, our last keynote speaker. It's Eben Haber. He's a researcher from IBM in San Jose. I'm told that as far as he can tell, his name is globally unique, so web searches can find all kinds of information about him. His background's in computer science, and he currently works in the area of human-computer interaction. He's never been a system administrator except for keeping his family's computers running, and he says he's been much happier about that since he hasn't had to administer Windows.
It's deprecated now.
It's deprecated, so it's a little bit, I guess. The reason he's talking here is that the past 7 years he's been working on a project to study system administrators in the wild, so the Jane Goodall of system administration. Last night in David Blank-Edelman's talk, you saw portrayals of sysadmins in Hollywood. Well, he's turned the cameras on us, and he's going to tell us what he thinks. So.
Okay, thank you. Good afternoon. I guess I'm the last speaker of the day. I'm all that stands between you and a night on the town, so I will try and keep this reasonably brief and to the point. Today, I am going to talk about you. Yep, that's right, you. Why? Because we like you. More importantly, because you are important. You are the foundation on which our society rests. Without the IT infrastructure that we all rely on, civilization would come to a grinding halt, and you are the people who keep it running. So you are very important. You just look back at all the work that went around the Y2K problem, or solving that, to see just how people consider IT is no longer optional. IT is what makes things go. But there's a problem here, and that's that you are expensive. Way back in the 1980s, if you bought a system, 2/3 of the cost would be hardware and software, and 1/3 of the cost would be people to run that. Nowadays, or by the year 2000, those numbers have flipped, and now it's somewhere north of 70% of the cost of a system is people to run it. Now, there are a couple reasons for that. I mean, in my opinion, one thing is that systems are a whole lot more complicated. You just look at a web server from 1995 compared to an e-commerce website now, and there are a few more moving parts these days. But the other thing is that computers every year get faster and cheaper, and well, our brains aren't any bigger than they were 1,000 years ago. Now, we do have better tools. That has helped. There are force multipliers out there, to borrow the word from yesterday, but they haven't kept up. The tools that we have on hand have not kept people as that same small fraction of system cost. So what do we do about this? Well, one idea came from way back in 2001 when an IBM executive suggested the idea of autonomic computing. Now, what if we could make IT systems smarter, able to configure, optimize, protect, heal themselves? And of course, looking at this, is this a bunch of early system administrators dealing with black box automation, or is this an early version of the LOPSA conference where this is the instructor teaching the use of new improved tools? So, at the time, what we were wondering is autonomic possible? There was a lot of debate at the time. Is this a meaningful concept? Can we actually have IT systems be like biological systems? And if you think about the way biological systems work, actually, autonomic isn't the best analogy. But computer science has had a history of increasing levels of abstraction, permitting users and administrators to interact at higher levels of abstraction with their system. So very few of us these days worry about page replacement policies. So computer systems have a page replacement policy that's good enough, and not very many of us need to look into that black box and find out. But, you know, 9 years on, it's been 9 years since this executive suggested autonomic computing. You know, IBM is not selling any autonomic computing systems. You can't go buy a system that's going to configure and heal itself and protect itself from your bad administration. But many aspects of hardware and software have improved, just not to that degree. But back in 2001, a bunch of people where I work were wondering, well, you know, is it possible? What does it mean? And you certainly can't automate or make autonomic anything that you don't understand. You have to know what it is that you're trying to automate. So a group of us decided to find out. And the technique that we decided to use is the idea of ethnography. And this is something that we borrowed from the field of anthropology. Ethnography is a tool for learning about unfamiliar groups by visiting them and observing their day-to-day activities. So, you know, IBM is really big on bringing people into labs, doing focus groups, but you really need to go out amongst the natives and see what happens in their day-to-day activities. We weren't really anthropologists, you know, we played them on TV, but we're actually computer scientists, and we didn't have 6 months or a year to spend working with you guys, understanding the full complexity of what you do. But we were able to make 16 visits of about a week each, following people around with video cameras, and we learned a lot about this. And I think, you know, popular culture doesn't necessarily portray you very well. No, I mean, perhaps that's because Hollywood doesn't portray anyone very well. They make everything more dramatic than it is in real life. But what we hope to do was get a more accurate understanding of who you are, what your work is, what kinds of tools you use, and then feed that back, hopefully, into things that IBM does, or just make it public in the world. Ethnography has some big limitations. It is hugely time intensive. I mean, you just imagine trying to stay focused, watching everything that somebody did for a day, and then do it again the next day, and then do it again the next day. And it also gives you a very small population sample. So, you know, all the results I have are just the people I saw. But everything you see out there in the field is real. I mean, you know, yes, people do act a little bit. They say, you know, they do try and do a little bit of show and tell. They do try and look good for the camera. But, you know, day 3, day 4, they really do have to get down to work eventually, and you get to see what they really do and how they really work. Ethnography is all about collecting and understanding stories of people. So I'm going to start with a story. And this is a video clip. This projector isn't ideal, but hopefully you'll be able to see what's going on. So this is the story of 2 database administrators, Christina and Mike, which is not their real names, because we do try and preserve their privacy and dignity a little bit. Yes. Well, I mean, they were willing to let us follow them around with cameras, so we ought to at least be nice to them about that. They were preparing to do a database tablespace move, which for DB2 was a very lengthy operation. They had a very narrow change window on a Saturday. They were spending an entire week practicing this thing on test systems, so they made sure that they had all the operations, they could get it done in the change window so that the customer would stay happy. This video was recorded on Friday, the day before the change window, and on this day they were preparing to do an online backup. An online backup because the database has to be, you know, the customer is still using the database, and then they're also preparing at the same time for the offline backup that's going to happen the next day. So let's see. Okay, good. Get started. So online backup today, offline tomorrow. So Mike's the more senior person who says, I was going to do this, but I'll let you do it. Have fun.
Did you turn from learning that and take learning?
Yes.
Okay.
So she's juggling a bunch of things. You know, talking about loading the tapes into the tape drives. They have to talk to the right guy to do that.
Yeah.
She almost did crontab-G, that would have deleted the crontab file. Those two keys are next to each other. But she's talking about online and offline, and they're right next to each other in the crontab file. And she's supposed to be doing online, but she actually searched on offline and got to the wrong line. And in her notes next to her, she also has online and offline, and how many tapes she needs for each one. So she's going to launch it with crontab. She checks the time. Okay, it's 15:58. She's good. Decides, okay, I guess I'll start this at 1600 hours. So she looks at it, she makes sure it's right. To make doubly sure, she runs date again just to get the time. So, 33 seconds to go until this is going to launch off. She looks at it some more, just to make sure.
What? No. No.
And she's so nervous she's having trouble closing the file and writing it. She uses a capital W first. Okay. She saves the file, but she doesn't know if it's been launched yet.
Well, is it running?
So there's no process.
Just do the page back.
But Mike suggests, check the logs just to make sure. Double check.
That log and just make sure. Good. I've been looking for it.
Well, I always normally do myself a couple minutes, and then I can always go back to it.
Yep.
It wasn't until I actually started looking at the time and the video timestamps and realized just how close she got to bringing the customer's database down on a Friday. So our first reaction, is we're computer scientists. We do spend a lot of time thinking about user interfaces, and we think, they're using crontab as a GUI. This is crazy. But what were they thinking? That was brought down the database. But when we thought about it more, we thought, well, actually, maybe it kind of makes sense for the kinds of things that they do, because all the commands customized for their sites with all the arguments laid out are right there. And furthermore, they didn't actually bring the database down. They had a time buffer. And I've never seen a database management GUI that actually, beyond saying, are you sure you want to do that? Gave you, 30 seconds or a minute to say, no, I actually didn't want to do that. So, there's something to what they were doing. Maybe they needed a few more comments saying, this is the offline one, don't do this one unless you really mean it, but, it's interesting to see their use of tools. Now, the other thing is that really struck us watching this is how risky this work is. Now, we heard from these people later, any unanticipated outage of a customer's database requires 40 hours of root cause analysis meetings. So that was what was driving their reaction. They were looking down the face of 40 hours of meetings if this thing went off. That's painful, Another thing is that as part of IT work, you have these really long involved processes. So for this table move, she had pages of instructions that had been handed to her by the last person who'd done the job. But she kept annotating them to make sure she had it right. And there was a body of scripts that came along with it for doing different parts of the task. And so she's juggling all these different things. She has to make sure that the guy, it's Friday, the guy isn't going to be in there on Saturday to load the tapes in the tape machine, so she's got to get it in tonight, and so she's talking about the offline and the online backup at the same time. And she gets the two mixed up in her head and goes to the wrong line in the crontab file. So, you know, we've got to consider just the number of things that these people are dealing with. And then finally, you know, regardless of whatever I think as a HCI type guy, you know, these people are going to build their own tools. They're going to take something general purpose like crontab and repurpose it, or they're going to build a script or do something to meet their needs, to meet whatever the needs are at their site. So after seeing stuff like this, we were hooked. We thought, this is amazing. This is stuff that we'd never been told before. It was stuff that wasn't written up anywhere we could find. That people who are designing middleware administration tools within IBM don't seem to know. And so we dove in. We did a bunch more stories. Sorry, I picked the random transition for all these things. So whatever comes up is just going to be random. We wrote a bunch of academic papers, which aren't particularly of interest to you. We did produce a tool prototypes, one of which ended up at least in 2004, 2005. We did work a lot with the IBM product groups to try and help them, but that's kind of pushing a boulder uphill. I mean, you know, I kind of understand. Okay, IBM is selling. You know, the people who buy IBM's middleware administration tools are not the people who use them. It's the CIO who makes the purchasing decision. And the CIO isn't sitting down there watching these people work and seeing where their pain points are. So the CIO has, well, it's got to have feature X and feature Y and feature Z. And so getting improvements that actually relate to the kinds of things you do is hard. And I've been working on it for a while. There are some things coming down the pipe and some things that I've been able to get in. But it's a long road to follow. And then finally, after many years, we decided to write a book. And so we're almost done. The book is aimed at anybody who wants to understand your work. So, you know, it might be appropriate for your manager, your CIO, for a Hollywood scriptwriter who wants to do a more accurate job of portraying you in a movie. And the book is centered entirely around the stories that we saw out in the field. And the book is almost complete, so I'm here to describe the findings and, you know, get feedback in case there's something that is really important about your work that you think we've missed. So, we have a contract with Oxford University Press. We have a working title, Information Technology Work. The cover art we're going to have to, you know, negotiate over time, but you know, I'm leaning towards something that will help it move off the shelves. And you know, if Oprah's book club picks it up, you know, we're golden.
Put the sun server in the background.
Setting sun. Okay, that'll be in the next version of this talk. So, the book has 7 chapters, with each chapter highlights an important aspect that we think exists in information technology work, in your work. It's only a coincidence that we came up with 7, but 7's great. You know, so there's 7 days of the week, 7 deadly sins, 7 rings of power created by Sauron for the dwarf lords in the halls of stone. You know, 7's everywhere. 7 pillars of IT work. So, people. And I'm going to talk about all these in just a bit. Technology, methods, tools, organizations, standardization, and communities. So I created Wordles based on the current text of the different chapters. The people chapter centers around stories about a guy named George, and I'm going to come back to him later in this talk. The people chapter is all about the incredible interpersonal complexity, collaboration, communication that goes on in IT work. IT systems have reached the point where a lot of times nobody understands the whole thing in detail. So you have to have teams of experts working together who have to bring their knowledge together to keep the system running and configured and so on. So we'll have some examples of that later on in this talk. The next chapter talks about technology and the extreme technical complexity of modern IT systems. And the example of this that I find just sort of the thing that I always like to point to is IBM has a practice called a crit sit, which stands for critical situation. When a system is working badly to a certain point, then a crit sit is called. And what happens is they bring all the responsible people into a conference room and say, okay, you're in here until the problem's fixed. So they have a database guy, a network guy, all the people they need. And sometimes that takes a day or a week or a month, or there was one case where we watched one that it took 2 months to resolve. A subtle interaction, a web application that would crash at random times, and it was because eventually they discovered it was because part of the web application was using an undocumented call to DB2, and you need to bring a lot of people together to debug difficult problems like this. Administrators hate crit sits. It totally disrupts everything that they do. But sometimes it's the only way to solve these really complicated interrelated problems. And it says something about where we are as far as technology, that we have to have something like a crit sit. Methods. The methods chapter is about the things people do to handle complexity and avoid risk. So, you saw Christine and Mike who used a cron tab, and they would set the time for something to go in the future so that they could have time to fix it if they realized they had done the wrong thing. They also did all kinds of other interesting things. For example, they were working on SAP, and they would never ever type a table name by hand, because SAP databases have around 25,000 tables, and at least the implementations we saw, all the tables were 8-character names. And so if you type one of those names by hand, you'd very likely get it wrong, or even worse, get the name of some other table. So there are lots of things that people do to sort of deal with this environment, and that's what we talk about in this chapter. Tools, I talk about all the things that people build on their own to make their environment work better. So scripts, cheat sheets, web pages, tool repositories, locally shared tools, all the stuff that we saw people making. And this local creativity seems to be a really critical aspect of system administration work. That systems tend to be really idiosyncratic. Every time you go to a different site, you see different arrangements, different policies, different practices, and people build their own tools to handle that. Organizations is about how it isn't just a few IT people who are keeping IT systems going. It's a bunch of organizations that have to work closely together. So you've got salespeople and transition managers, and the people who build the systems, and the people who configure the systems, and tech support, and all these people have to work together to make information technology happen. Standardization is about how sites will adopt formally well-defined practices, tools, and so on to improve the interoperability, both in terms of technologies and in terms of people. If you do the same thing on if you do things the same way on every project, then you can move people from project to project easily. But top-down standards don't always take into account all the details of a particular site, and they don't always capture sort of the full richness of the environment. So this is a tricky balance. And there can be a tension between building something custom for your own situation and having standardization. And then finally, communities. The communities chapter comes out of examples that we saw studying security administrators. Security administrators are great. They are fascinating. They're really, security administrators, when you watch them, you think that they are paranoid until you realize there really are people out to get them. They have human adversaries. Most programs don't care if you fix a bug, but somebody attacking your system can get really mad. Cool. Let there be light. I didn't do anything up here.
Time's up.
So these security administrators work not just at a site level or a group level, they work as a community. and they're practicing information warfare. They are trying to share information with their friends about the people who are attacking them and keep information from the people who are attacking them. And at the same time, the community of people who are attacking them are doing the same thing. They're sharing tools, they're sharing exploits, and they're sharing information. And it's really wild to watch this in action. But for them, you know, IT is a community activity. They are sharing information, sharing tools. And I mean, certainly open source tools, which are very common in IT, are another example, but you know, not quite as dramatic. I really don't think there's any light switch that I touched.
Now working on it.
Okay, so for the rest of this, so that's about what the book is about. And for the rest of this talk, I'm going to just go over some films that I shot of one particular character from one particular chapter, the people chapter. And it does highlight a lot of examples from our book. And this is the saga of George. Let's see, wait if they can get the lights down a little bit before I roll the film. And George is working with his colleague Thad, and they were working on a couple things related to customer requirement. Words, 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 words. No, actually, this one there isn't so much to see in the first clip, so get this going.
I've done two problems at once, but I have, well, that is kind of handling one of them is a problem related to web seal not starting on our
But this is the issue, yes, from yesterday with the group permissions.
Same issue, yeah. So I figured that out, and actually what he's doing now is actually uninstalling and reinstalling the product, because that's what we've gotten down to. We can't turn away the product. So, what I'm working on is, you know, basically there's a new environment that the customer is setting up regarding they're going to have web seal on the front end server, and basically web seal is going to have junctions to back end Domino servers where the employees are then going and access their mail over secure web interface from the Domino. It's going to access from the Domino server. So basically we're creating we were waiting on a new IP address for the web seal server, and we need firewall ports open between the web seal server and the back end Domino server, so that they can talk to each other. And right now, I was told that the IP address for the web seal server is in place, so they want me to try creating the new web seal instance on the server. So that's what I'm about to do.
Okay, great.
Okay, so George is a web administrator, and what he was describing was that at their customer site, they have an existing server, they've got a firewall, they've got an authentication server in the middle, and he's supposed to create a new instance and allow it to connect to the mail server in the back end. And he's waiting for the holes in the firewall, but he does have the IP address for the new instance. So this is kind of this is what we reconstructed of how he was talking about things. He never wrote a diagram like this, but we sort of built it ourselves to help ourselves understand it. And it seems like there's some nice things going on, that all the odd-numbered firewall ports are going one way, all the even-numbered ports are going the other way, and so there's a nice symmetry to the whole thing. So, George was new to this particular task. He hadn't done it before. His colleague Thad, who keeps helping him out, had done it before and sort of knew more stuff. And so in the next clip, we see him getting ready to create the new instance and running into some problems. So he's browsing the online docs. He actually finds some really nice online docs that describe exactly the kind of task that he's trying to do. Gives sample commands, what to do in different config files. He looks at the config file that he needs to do, that he needs to change. He copies some IP addresses from another place and puts them in the config file. You know, pretty standard stuff. Once he's done modifying the configuration file, he tries to restart it. You know, says runs the appropriate command. It stops the existing server. It's supposed to be reloading it with the new information. Could not start the server. So okay, well, he's not sure exactly what's wrong, so he's going to undo his changes from the file. And so he takes out a line from the configuration file, writes it out, and does the same command. Yeah, okay, same error. But you know, he's smart and he made a copy of the configuration file in another directory, so he's going to copy it back and then try and restart it. And same error. So there must be something more that's wrong here. It's not just the changes he was making. So yeah, he goes to look in the log file. And there isn't anything obvious there. I mean, and one of the problems is there's always errors in these log files. But you know, in this case, nothing that he could see.
It's not working.
His coworker finds the problem.
What we have is the server that he's working on, the server that I'm working on. My server has WebSeal, which is a policy director component on it. The server that he's working on has WebSeal and policy director server. Now WebSeal needs to talk to policy director server. Well, he brought his down. So mine can't talk with it. Right.
But that wasn't all. So that was supposed to be working on this.
The server that doesn't reside here in the USA, the one that Thatch it has some other security problem that we think may be causing the problem. Which we're having permission and stuff like that. And the product that they have, what is that product called?
Which one?
COS?
COS, it's SCOS.
Yeah, COS it's called, and then supposedly it does some kind of security against user IDs and
everything.
stuff like that.
Permissions, all this stuff. So
Yeah.
that's everything for you.
So we're trying to get them to turn that off at this point and see because you can't even get ahead. You can't even proceed with the install at this point because he's getting all kinds of errors.
I see.
So we're hoping that maybe it's related to that.
So one more layer.
Although it should have been first in the chat.
I didn't even know it was there.
I know it's there.
You did.
But I figured that, you know, it was on the box before, so nothing had changed, you know, it was always on the box, so why would that make a difference? But they must have did a policy change on their side somewhere.
Nothing had changed. It was always on the box. Yeah, this kind of debugging session was really something that we saw a lot, where somebody makes a change, it doesn't work, they try and undo the change, but then they realize that there's something else going on, another level on this. You know, in this case, George was trying to do something, but he couldn't because Thad was trying to reinstall something else, but then Thad was trying to figure out why he couldn't reinstall what he was reinstalling, and it turned out that, well, they thought that there was this security thing, and they were trying to get it turned off, and there was no way that they could do it, they had to convince somebody else to do it. So, and I think that is an important thing to consider, that there are lots of layers, lots of people working on different parts of these systems, and it's all interrelated. Now, eventually they found a solution. I'm not sure exactly what the solution was. We weren't there when they found it, but they'd been talking about running the PE server as root, or a couple other options. So whatever they did, George was able to create the new instance. And when George created that instance, in the instructions he found online, it said something like, use this command, pdwebconfig-i instance-m internal port. Now, it didn't really define what instance or internal port was, but George thought he knew, and so he filled in some values there. And so the way he thought it was going to work was like this, and this is kind of what I showed you before. And in the next clip, George has already created the new instance of the web server, and now he's trying to configure the authentication server in the middleware to allow the front-end server to access the right back-end resources. Cool. Let's see. Okay, I guess this one doesn't start automatically. So in these clips, we have a few snapshots of George trying to configure this new. No, I guess. Or it is. Start that again. Okay, so we've got George trying to configure the new server. The syntax is new to him, so he's trying lots of different possibilities, filling it in. He keeps getting odd errors: server not found, could not connect to server. He's not sure whether he's got the syntax wrong or the or there's an underlying problem. And he finally finds a workaround. He can't get it to work with his new front-end server, but he can configure it to work with the previously existing one. So he tells his manager that, and then his manager says, well, why don't you work with the product, with the application architect to figure out what the problem is. And George assumes that the architect has been around, knows what he's doing, although the architect kind of has a high-level view. He's not as familiar with all the low-level syntax stuff. But, you know, George starts to brief the architect on where they're at.
Well, at this point, I'll tell you where we're at. I created the second instance on the 101 server, the acceptance server. It seemed to go fine. It seems to be running no trouble there. When I went to create the junction to the domino servers from that instance, it gave me a message, something like, could not find server or something, could not connect the server. Made sure it was running. Everything was okay. I'm not sure why I didn't accept the approach.
Okay, so one of the first things that they do while working together is to get more information about the error. So he did what just about every other sysadmin we saw do was with an unfamiliar error, is that he copies it, he goes to Google, pastes it in. Yeah, he did have to play around a little bit to get the, with the search terms, because when he pasted the whole error message in, it didn't match. But then he refined it, added quotes, removed quotes. We just got down to the hex error message. And he finally finds an index of all the error messages, and he finds this really useful thing that says, explanation, see message, could not connect to server. Make sure server is running and accepting connections. and since this software was actually created by my employer, I can make all the fun of it I want to. Yeah. Error, could not connect to server. Well, he's configuring a middleware authentication server to allow a front-end web server to talk to a back-end mail server. So what does that mean exactly? If it had said could not connect to server XYZ on port whatever, this would have been a lot less interesting to watch. But, when I went to product groups and said, you've really got to do something about these error messages, I found that is actually one of the hardest things for them to do. Because especially a company like IBM, well, the product has to be sold in 37 countries, it has to be available in 26 languages, all the error messages have to be shipped off to be internationalized and localized, at least a month before the software is actually done, and they pay per word, so the shorter the error messages, the better. And unfortunately, sort of your trouble on the front lines doesn't register as a cost in development, whereas, internationalizing a longer, more detailed error message does. We haven't found a solution for this yet. We are working on it. So all through this, we have this kind of model of remote debugging, where we have this architect who's talking to George over the phone, and then George is working on the system. And so everything is mediated through George. The architect didn't have access to the system. Only George could do that. And eventually, the architect sort of threw up his hands and said, well, I can't figure out why this is happening. You should call tech support. And George wasn't very optimistic about this approach.
It seems to be the generic solution, the fix all, reinstall, reinstall. I made the mistake of trying to do an upgrade from 3.8 to 3.9, and what is that?
Reinstall, reinstall. That's his view of what support is going to tell him. So, but once support joins, then we have tech support who is working with George, and the architect is working with George. But at some point, George's manager asked Thad to help him, and so Thad actually has his own access to the systems involved. So at least in that case, it doesn't all have to go through George. But with the architect and tech support, everything has to go through George.
Who is tech support?
So
Is that IBM or?
Well, it was tech support for the product, and the product came from IBM. So it was an IBM tech support person, but you know, they were calling the product. And I mean, yeah, and sometimes, you know, it's like if you're dealing with a complicated system made up of multiple pieces, then you have to call either multiple tech support people, or if you're lucky, they're from the same vendor. If they're not, then each vendor will blame the other one. And so the interactions with tech support actually started out okay. So George, he explains what the command was, he explains what the error was. Support says, can you email me the log? George asks, okay, which log? And at the same time, Thad was in his office talking to him, and then Thad sends him a whole bunch of instant messages about, okay, well, I see this, and I see this, and this whole thing sucks. And then support comes back and says, okay, yeah, I'm looking at the log. And he's talking to, and George is now talking with the architect on the phone, so he's Grand Central Station as far as information coming and going. Okay, now support says, can you verify that the port is listening on the right machine? This is actually the right question. George runs netstat.
1734. This is the ha.
So this is where this turns into a tragedy. George just saw and then dismissed the cause of the problem. So in this nice architecture, all the even numbered ports are going one way for communication, and all the odd numbered ports are going the other way. And George just saw on the machine running the front-end servers an odd number and an even number. So that almost clicked in his head, but something overrode it. And you know, George, when he was creating this instance, it only had one argument for the port. Which one is it? Is it the one going this way or the one going this way? He didn't know. He thought it was one way. In fact, it turns out it was the other way. But at this point, the problem is no longer debugging the system. The problem is debugging the system administrator. And that can be much harder. It wasn't, now, George then responds to tech support in such a way that kind of confuses tech support, and tech support doesn't answer in a way that helps things at all. So let's see, this is just more of that. So tech support says, George says, it is listening on 7234. Is it okay that it listens on the same port as the other instance?
Just to keep you updated, the guy from support he made me check to ensure that it was listening on the 7234 port, and it is. My question to him is, do you need to listen on a different port for the second instance? Because the first instance listens on the 7234. So there's a second instance. Oh God, this support guy is asking me for a web seal admin guide. I swear.
I'm saying something somebody else say approved.
The support guy is asking me for the web seal admin guide. Says he's working from home and he's trying to find it. We're in trouble there.
So the George told the tech support guy that both instances of the web server were listening on the same port, which wouldn't work. But George is mixed up at this point. And so the tech support guy says, I don't think so, but do you have the web seal admin guide? Which was the wrong thing to say, because that's a good way of losing any trust that the person might have had in you. And so at this point, George gives up on tech support. Tech support had actually asked the right question, which if George had been thinking about it, would have led him to the right answer. But instead, George loses all faith in tech support and moves on with the architect and Thad. And so Thad is working on it. George is trying to debug it with the architect. And about 15 minutes later, Thad has an insight. And Thad first tries to just sort of tell George what the answer is, but then Thad realizes that Thad has to debug George himself. So let's see. Here it goes. So they're doing IAM. Thad says, you specified the wrong port. No, I didn't. You did it wrong. We just didn't tell it to go both ways. So they're arguing back and forth about the port configuration. Thad has the answer. Just use this port. There's that's where the firewall's open. Just use this. And George is like, no, that port has nothing to do with it. And finally, George sort of just can't take the IAM anymore. Oh, and Thad says, all I know is what I see in the config file. So Thad can see the config file. We thought it was the return port. That is not a return port. Thad says, there's no listener for this port on the machine that you think it would be communicating to. Use this other port.
Can you please call me? Please.
Thad says, just do it.
Dad. Hey. What are you talking about? 7236.
Yeah.
We thought that it came in on 7137 and went back on 7236, but we were wrong. 7236 is like a HTTPS listener port or something.
It will still come in on 7135 to talk to the PE server apparently.
Right.
What's happening is it's actually trying to make a request back through the 72, well, it's trying to make it back through the 7137 to the client.
Right. Right. And I know that, but I can't tell it to you.
Yes, just create it with 7236. Trust me.
Why? That port's not, that's going the wrong, that's only one way too.
Trust me.
It's only one way.
Do it.
Do you understand what I'm saying?
Just do it. It only has to be one way, man.
Why?
But it's the PD server talking back to the web seal server.
Yeah, but how does the web seal talk to the PD to make some kind of request?
7135 is the standard port that it uses in all cases. So we had it wrong. Our assumption on how it works was incorrect.
Alright.
Please just try it. If it doesn't work, it can beat me up after that.
I want it right now.
So debugging people is really hard. Debugging mental states. And also think about it. Think about the limitations of the different communications media. I don't think the communications with tech support would have gone quite so badly had they not been over IM. Over IM, there's no nuance, there's no what do you mean. It all has to be complete sentences. And so I somehow suspect that when George had said, both instances are listening on the same port, I suspect that tech support might have said, well, that doesn't make any sense. Are you sure? so doing it over voice might have worked better, and also between Thad and George, the debugging session, IM really didn't work. Voice worked a little bit better. But I think if they were both standing in the same office with a whiteboard and started drawing pictures like I showed you, things might have worked a lot better. So we have 2 more quick clips. One is...
Yeah,
that's what I'm gonna do.
I'm telling you, man, this is what's happening. You can see by the connection. It's trying to make, there is no 7137 listener on H50 right now. So
that's still pushing on it.
Yeah, I understand what you're saying.
And sure, we could do this in the long, but I think we're out of there where we thought that was the issue. It's trying to make a return port. I verified in the other web to the log that the SSL port is actually just the 234 port.
I understand what you're saying. Just relax. I need a minute to do it.
Okay.
I can't say because I got 2 people in the room.
Hey, Thad. We'll call you back when we find something. There's no reason to find the phone.
There's too many people. I hate when there's too many people. Like one time to do something different. It's like you only do one thing at a time.
So Thad was still trying to push on it, still trying to make George understand, and George had sort of reached his saturation point. And he was Grand Central Station for a while there. Everything was going through him, and he just sort of reached the limit. But he understood what Thad was saying enough to follow through on it. And in the final clip, we say, okay, all junctions are done. You are demand, says George. I will never question you again. And Thad says, it worked? Oh, I was just kidding. Lunch? No, I gotta run out. And then Thad says, punch me later? No, kiss you. So that's our happy ending. And this was sort of one story from one chapter of our book, but it highlights a lot of the aspects of what is going on. That collaboration and communication between people is really critical in understanding these systems, in debugging the systems, and in fixing them. The technology is way too complicated, and it's only getting worse. And with our other stories, we've got great examples of administrators over time who develop lots of methods and tools for handling their environment. And how standardization does help to a certain degree, but it can be difficult because, especially in IT is a crazy thing. Sites are very idiosyncratic. And finally, much of what goes on is community work. We've got great open source tools. We've got a community of practice like LOPSA, like Lisa, where people help each other out. And how do we leverage all those things? So when people ask me, okay, well, what do you do? And I say, well, okay, last couple of years I've been spending a lot of time studying system administrators. Well, what have you learned? It's like, oh, well, I'm writing a book. I'll give you the book. But if I needed to sum it up, you guys work in an environment of large scale, very high complexity, and risk. Risk is a very important thing. You work in that environment, you manage that environment through collaboration with each other, through creativity. Administrative work is very improvisational. It's like, okay, well this didn't work, let's try this. And continual learning. There are lots of open issues. How do we balance the local creativity, all the great things that people build at the ground level, with standardization? How do you find the right balance there? How could we help communication between people? How could we help Thad and George debug their understanding of the system? How do we give them ways of sharing what they're seeing in the system? Is autonomic possible? Certainly not yet. We can automate fairly complicated technical things like jet engines. You know, there used to be a third person in the cockpit of every jet, nursing the jet engine and making it perform correctly, and that's all been automated now. But you know, is IT as complicated as a jet engine, or maybe it's more complicated? Maybe IT is so idiosyncratic and so different and so customized at every site that we can't imagine a way of having a generic box that you just drop down that will do the right thing for any given customer. And cost, I mean, yes, you are expensive, but it seems to be a product of the environment and how you deal with it. And the fact that tools, while they improve, haven't improved enough to keep up with the complexity. So finally, you know, I want to end up with a question. If there's going to be a book out there about you, what should be in it? What have we missed? What's important? And I'll get my pen so I can write all this stuff down. There's a mic. You can or raise your hand, either way.
Well, there's something I'm fond of, and you sort of touched on, is ability to multiplex effectively. And the ability to handle change and unpredictability. So, for instance, a programmer will go in and they're working on their, you know, Java whatnot, like, you know, their little module or whatever. A sysadmin goes in and says, okay, I'm going to do this, I've got these support tickets, I've got this meeting at noon, and boom, a denial of service attack. Okay. Now, if you're working in an environment where what you do is yanked out from under you on occasion, or bad places, there's a lot, you're going to put that down and go become a programmer because you like to sit in the room alone, you know. And I really enjoyed the interaction, and that's one of the reasons I like systems management. But I think that computers are like pencils and typewriters. Every company is going to be configuring those things for the attentions of core goals of that company. So even when you even have, say, multiple banks, okay, let's assume they all have the same job, they're going to be different because their management structure is different.
Local practices and local standards.
Local practices, government regulations, they have to differ state by state, or even just how savvy the IT department is. You know, do they really have a jerk on top who does nothing but, oh, well, it's just one of those players. I don't care what the rest of the world is doing. Or is there an innovative leader who has another section of this group that just really does experimental stuff so they can test some of the rising new technology?
Or worst of all, lots and lots of innovative people who are all going in different directions.
But really, in many ways, systems management is juggling. We're juggling lots of different applications and trying to get them to interact with each other. And that mix of applications is going to be different at every endeavor also. So, but I think you are exactly right. People who do stay with systems administration are people who like to continually learn something.
Well, I guess I can agree with you in just about everything you said, so thank you. Yes?
The component of that, you touched on supervising. I think there's a component that mirrors that, and many of our existing needs as well, that most system administrators develop intuition and conceptual modeling of the systems they work on, and therefore have a sense of how they ought to behave and how they generally behave. Those are my sense of time on it as well.
Okay.
Actually, since what I was going to say is almost exactly on the point. A lot of the knowledge we gain of our systems is very transient. We work out how some model for how something is supposed to be. We adjust when something happens, and then I've learned a little bit more about how this particular maintenance script fails or something. But at least in my experience, we're really bad about either spreading that information and especially storing that information. I can't help but think if these guys had had the graphic that you designed for the slideshow, I don't think they'd have spent a fraction of this time solving.
Yeah, absolutely. And I mean, that sort of falls into what I've been talking about, collaboration. One of the things I've been working with within IBM is, IBM has a bunch of tools for managing systems, but I've been trying to get them to add freeform annotations, so that anybody who makes a change to a system can just put a freeform annotation on there that is a first-class piece of information about that object. Because that way, when you look at a system, you can see all the things that people have said about it. And really interestingly, well, you can also, if you come in the morning, you can say, oh, well, what systems are healthy, what systems aren't healthy, and what systems have a whole bunch of annotations that have just been added. Tom?
So, I'm not exactly sure how to ask this. So the wrong way to ask this, did you discover any system administrators have secret superpowers? And the reason I ask this, and I've never said this before in public, but I am awesome at cutting paste. If there was an Olympics in cutting paste, I would win the decathlon every time. And I watch a lot of my coworkers, and it's so frustrating to see that they're good, but not as good as me. No offense, but I wonder if, and I think every system administrator has some kind of superpower like that. And I was just wondering if you notice any superpowers as we were watching.
Huh. I guess I haven't thought about it that way. I mean, sort of different people seem to be good at different things. Be it, this person's really good at logging everything they do and organizing it in such a way that they can draw upon that information later. And somebody else is really good at knowing who to ask when there's a problem. And somebody else is really good at scripting and making a script in the moment to answer some question that everybody has. And so.
Did you look at interaction of those experts?
Well.
Did the logging guy feed the person who found the right person with the log?
Well, that is kind of what the crit sit that I watched was like, because when you get to when you get to the level of a crit sit, you bring the senior people in because you want to solve it as quickly as possible, and so they're having really interesting discussions. You got 10 people in the room and 6 or 7 discussions and people moving around from table to table, and they're coming up with ideas and trying things out and experimenting and drawing stuff from the whiteboard. It's a very interesting thing to watch and kind of hard to sort of to grasp as a whole. But and I mean, I think that is why that practice exists, because if you had all those people on a conference call, it wouldn't work that way. You need to have them in the same space so that they can actually walk up to each other face to face, or draw stuff or show stuff to each other on their screens. You raised your hand first.
So I think this kind of brings something home. A lot of outsiders see computing as something totally logical. And it kind of pains me when I hear system administrators say, because anyone who's been in computing long enough knows that every decision about a computer is made by a person. Programmers make decisions, or make that decision, or system administrators make that decision.
Even chaotic systems are deterministic.
Right. I think what would benefit us as a community is maybe showing or drawing other components from other disciplines that we can then look at and see where other people have been with such complex problems. This isn't anything new. This is something that humanity was struggling with since the beginning of time. And so what are the disciplines that are available to us that we can draw upon?
Well, I mean, that's a very good question, and I don't have a good answer for other disciplines that are really on the cutting edge like this. I mean, it seems like other disciplines, architecture, whatever, they find some, or engineering, they find some solution to a problem and they use it. And, it becomes established practice. In IT, it still seems to be very much everything is a custom-built thing, and you're pushing it as far as you can because the business wants to get the maximum utilization out of the investment in the infrastructure. And so so they're not willing to just sort of buy a black box that will do X. They want to they want to get X plus 2 out of it. Let's see, Dave.
Three things. The first is a question. How are you going to put the clips in the book?
Okay, so we don't put the clips in the book, and we don't even want to distribute the videos because these people were nice enough to let them follow them around.
But how do you tell that story without making them just sound like idiots? How do you show the?
You just say you did.
Well, we do our best in providing quotes and a storyline to bring the reader along and to express what's going on. And I think it does work.
Okay.
I mean, it's definitely not as compelling as video. I mean, if you ever want to demonstrate to management problems that people are having, just bring in a video camera, because you can show people statistics till the cows come home. But if you show them a video of somebody pulling their hair out about something, it really drives the point home.
So the one for your list, which was hinted at in a lot of what we talked about, is debugging skills. The people who have some, that's a superpower for Tom. Some people are really good at just asking the right questions to break down the problem, even if they don't know anything about. In fact, sometimes it's better if they don't know anything about what they're debugging. The third is, so in the two clips you showed, one they were collaborating right next to each other, and the other started out actually individual, and then some IMing. Do you have much about group work and team, how you interact? You talk about
Yes.
the communications meeting, but
yes. So the chapter on organizations talks about both how to structure an organization so that people within the organization work well together, but also how the organization works well with other organizations. So we do talk about that. That's another topic. Yes?
We have about, you take one more question.
Okay.
We're going to be getting rushed out here, so sorry.
Let's see. Who had their hand up first? Okay.
Two things. One is that IT is a moving target, and so that makes it different from lots of other things that you might try to draw analogies to. One thing that I think you're missing is I think a lot of sysadmins are essentially too in love with technology. In the situation there, they were IMing, they were doing things like that. But, finally he got frustrated and he made a phone call. And the next level after that then is to go and actually go to the office. And the thing that really hit me was, after the whole thing was finished, he's like, so you want to grab lunch? And I was like, they're on the same site? Why the hell didn't he walk over 15 minutes ago? And the same thing happens with your quick six. It's like, not until this is a really bad problem do we actually bother putting people in the room together. And I think that's something that I see it at my workplace too. Is people IM stuff a lot. IM is for deciding when you want to go to lunch, not for debugging a problem.
But well, actually, IM is really good for sharing error messages.
Yes.
For sharing commands. Email's better for log files. Face-to-face is best for actually debugging people.
But if you're both looking at the same screen, Tad would have seen, or Thad or whatever, he would have seen, wait, that's an important, it's not important.
Yep.
That's a problem.
Yes.
Whereas nobody else saw that.
Yes, and that is a point that we make, that everything was mediated through George until Thad came along.
Well, but it's not that it was mediated through George. It was mediated through George via technology, not via, not having a second set of eyes actually looking at what's happening. And I think that's a big.
Yes, and I mean, sharing awareness of systems is another thing I'm working on. And I'm told that we're done, so thank you very much.